Hello students, welcome back to my channel CGAT Maths. Myself Dr. Suresh Biradar. In this video, we are going to discuss an example based on Cauchy integral formula. In the last example, we have discussed the derivation of a Cauchy integral formula. Okay, I will give the link in the description box. You just go through that and will know more idea to solve this exam. Okay, so first I am going to write Cauchy integral formula, then I am going to derive this. What is Cauchy integral formula? You people already have here. If fz is analytic inside and on the simple closed curve C and A is any point within it, then f of A is equal to 1 by 2 by I integration of f of z divided by z minus a into dz over a curve C. So it is very easy one, students. Everybody will understand this example. Just concentrate carefully. Okay. Look at this is fz divided by z minus a. Just compare these two and write it. What is f of z here? F of z is e raised to z. And what is the point here? Point A value. A is equal to, this is I pi. This is minus minus, so just write I pi. In case of a plus, it will become minus of I pi. So A is equal to I pi is a point, means if I write in the Cartesian form, this point becomes I means a imaginary. This is 0 comma. Okay, let us draw this in terms of a Cartesian geometry. Okay. First, I am going to discuss based on the first curve, that is A is equal to what? Modulus of Z is equal to 2 pi. So what does this represent? It represents a circle with the center at origin, and the radius is 2 pi. Okay, so radius is 2. So how to evaluate this integral over this curve? Okay, first you can check here the point. You know Cauchy integral formula very well. There should be a what? Point inside this circle itself. Okay. Point 0 comma pi. 0 comma pi is somewhere here, because this is up to this length, from origin to this is 2 pi radius. 0 comma pi should be definitely inside this. So what is your conclusion here? The point, okay, write neatly, the point z is equal to a is equal to I pi, or you can also write p is equal to 0 comma pi, okay, lies within the circle. What is circle? Modulus of z is equal to 2 pi. So by Cauchy integral formula, by Cauchy integral formula, this Cauchy integral formula, here it is. Okay. Just cross multiply it. Okay. Right in the reverse order. Integration of f of z divided by z minus a dz over a curve C is equal to 2 pi I into f of a. Okay, just cross multiply. So here this will become integration over a curve C e raised to z divided by z minus a, z minus not a, z minus I pi into dz is equal to 2 pi I into f of a value is I pi. Okay. So this is 2 pi I into f of I pi. You know f of z. Substitute z by I pi. What will get? E raised to z is I pi. We know that e raised to I theta is equal to cos theta plus I sin theta. Okay. So this will become 2 pi I into cos pi plus I sin pi. So cos pi value is minus 1, sin pi value is 0. So this is 2 pi I into minus 1 or minus 2 pi I. So what is your conclusion in case of first? Therefore, integration of e raised to z divided by z minus I pi over a curve C circle with center at origin and radius 2 pi is equal to minus 2 pi I is the answer. Now let me go for a second curve. Second curve is modulus of z is equal to pi by 2. What does modulus of z is equal to pi by 2? Okay. So it is again a representative of a circle. Representative what? Circle with center at origin means 0 comma 0 and radius r is equal to pi by 2. Okay, let us draw a diagram again with respect to this. First you can draw a diagram. This is the circle. Here radius is pi by 2. Okay, and observe our point. So this is I have drawn a diagram, but what we have a point. The point, what is the point? The point z equal to a, which is I pi, or you can also call it as a point is equal to 0 comma pi. Where does this 0 comma pi lies? It is outside this circle, that is pi by 2. So pi is greater than pi by 2, probably this is 0 comma pi lies outside the circle. Okay, so if it is lies outside the circle means, so what will happen if it is lies outside the circle means the point you can write lies outside the circle, modulus of z is equal to pi by 2, and this is e raised to z, e raised to z divided by z minus I pi is analytic. Inside and on the circle modulus of z is equal to pi by 2. Then by Cauchy's theorem, integration of e raised to z divided by z minus I pi over the curve C into dz equal to 0. Directly you can write, if it is lies outside this circle, directly what will happen? Integration of f of z divided by z minus a dz is equal to 0. That's it. Thank you so much for watching. If you find any doubt in this videos, please don't forget to mention your comments. Thank you.